Okay, so let's complete this concept of Coriolis with this nice animation. Very simple. So let's look at where is my cursor? Can I do that? Okay. So I should find my cursor. Anyway, this is what I had said. If you launched a rocket full of chocolates towards, in this case, the Galapagos from Santa Claus's abode, let's say he launched a rocket on Christmas night, then because he had zero eastward velocity, because the rocket had zero eastward velocity at the North Pole, and the Earth is moving faster and faster as it comes to lower latitudes, going east because of rotation, the rocket is going to miss the target and going to veer to the west, so to the right of the direction of motion, north to south. Let's launch it the other way. Whoops, that's the same one where there is no rotation, so it can go straight without any of this Coriolis effect, right? Let's launch east to west. Even if you launch east to west, as I said, because of the centrifugal force on a merry-go-round, if you're standing on a merry-go-round and holding on to something and you let it go, you're going to fly off. That's the same thing. So no rotation, no problem. But if you add rotation, you're obviously going to be tilted again to the right of the direction of motion in the northern hemisphere. As I said, this centrifugal force has a little component towards gravity when you go east, and it will have against gravity when you go west. So theoretically, if you wanted to accomplish a little bit of reduction in gravity when you are launching a rocket to space, you would launch facing west. But the more important thing that happens when we launch rockets is that if you notice, most of the rockets are launched from as low a latitude as possible. The French go to their colonies on the equator or in the tropics, whereas the US launches from Florida, which is one of its southernmost latitudes. Why? Because the momentum or the speed of the Earth that the rocket will carry into space corresponds to the latitude at which it is launched. So if you launch from a lower latitude, you're going to carry higher eastward velocity as you go into space, and that's going to help you get into the orbit and attain your speed and so on. You want to spend as little energy as possible because you don't want to strap on a huge load of fuel onto a rocket. You want to be as light as possible. So using the angular momentum of the Earth or the eastward velocity of the Earth is obviously going to help. I hope that kind of cements the concept of Coriolis. We'll come and look at the impact of Coriolis effect on the circulation and the cells that we talked about. Again, important concept, get it understood completely and carry it and be able to apply it in every situation.